Alright, hello and welcome to our tutorial today on Solver, the add-in for Microsoft Excel. Solver is probably one of the most popular add-ins that we use, at least in class, for Microsoft Excel. And what it is a solver that has the ability to maintain constraints. So it's a data modeling tool that you can use for a variety of things. And it seems pretty simple at first when you get started because it is pretty easy just to click around and manipulate the buttons or the settings in Solver. What I have found over my years of using this particular aspect of Excel is the problem is more in understanding the problem and building the business model versus actually clicking the buttons in Excel. So before we get started, here's the first thing you need to know about Solver. Solver is an add-in for excuse me, for Excel, which means that by default it is not there. Now on my particular program it is not either. It should be floating around right over here. So what we're going to do is we're going to activate Solver before we solve this problem. So we're going to jump in here. We go backstage. From backstage we're going to go to options. From options we're going to click add-ins. Okay. From add-ins we go to Excel add-ins and we're going to click go. We're going to click Solver, like so, click OK, and voila, we have Solver installed and ready to go. So now let's look at our problem. This is an interesting problem. Okay, here's a particular problem we've got. Let's just say that we are the managers of a supermarket. The supermarket is very small. We can say it's almost like a vegetable stand or something like that. And you have 2 full-time employees and 3 part-time employees that are available for you to work for the week. Okay, 2 full-time, 3 part-time. We have 200 hours that we need to fill to work within the week. Okay, we have 200 hours that we need to fill within this span of time. Okay, so the trick with it is our goal in this particular problem is to minimize the amount of wages we are spending while we are also filling those 200 hours. Okay, so the goal is we need to set up a schedule to fill 200 hours, but we also want to do that in a method that uses the least amount of resources available. Okay, so now there are a couple other caveats here. So we got 3 part-time employees. Those part-time employees make less than the full-time employees, but also they cannot work more than 30 hours. On top of that, we have 2 full-time employees, which means that they must work at least 30 hours to maintain their full-time status, or over 30 hours, and they cannot work or exceed more than 80 hours in a week, which would just be cruel and unusual anyway. And as we go into this problem, we may drop that from 80 down to 70 just to see how it works. So let's go ahead and jump into this problem and see how we get started. So before we do it, I'm going to click this Formulas tab and point out 2 things: precedence and dependence. When you're building a data model in Excel, specifically to be used with any of the what-if analysis tools, Solver, Data Table, well, not so much data tables, but Solver, GoalSeek, Scenario Manager, one thing you'll see is that you have to have precedent and dependent cells. A dependent cell is a cell that derives its value from input cells. Those input cells would be precedents. What you need to understand when you're building a data model in Excel is that Excel doesn't understand anything. Excel is a glorified calculator. It's the glorified abacus. It's just a very, very fast counting machine. It can solve for X, it can solve for Y, but it doesn't really understand what X and Y really is. Okay, so in this particular case, what you need to do here is you have to tell Excel the relationships between all these different things in order for it to help you solve the problem that you choose. So here's a couple tricks that I like to use, and you don't have to do this in order to make Solver work. But when I'm building these data models, first thing I often do is I convert this to a data table, like so. Okay, so to do that, to convert a data set to a data table, well, you can highlight the set and hit Control T, or you can highlight the set, go to Insert, and select Table. Okay, like so. Now it didn't do it because I've already converted it to a table, but that's how you do it. Once I do that, my next step is I'm going to go into Table Design and click the Total Row. Okay, that's going to turn on aggregates, which means that I instantly, if I go in and I click Sum here, I instantly go in and I have precedence and dependence, right? Because this is going to automatically sum up the data that's above it, right? Like so. Like so. Now, how do I know it worked? If I go to Formulas and I go to Trace Precedence, look at that. If I click this cell and I go to Trace Precedence, look at that. We're set to go. Okay. Now this is just a formula auditing tool, which you don't necessarily need to do. Just a little double check to make sure that this model is going to work. So I'm going to click over here, click remove, and we are ready to start building. Now, we don't have any actual functions or formulas in here yet. So this total earnings doesn't have anything in it. The hours worked, that's what Excel is going to solve for. So the first thing we need to do is give it a formula or equation or something to tell it what the total earnings is going to be. So here's what we're going to do. We're going to do this. Okay, we're going to hit the equals key. We're going to take their hourly wage and we are going to multiply it by the hours worked. Now, even though we don't know what the hours worked would be just yet, that doesn't really matter. Excuse me. Because Excel is going to do that for us. Excel's going to fill that out. So right now it's got zeros, but that's okay because that's what we're going to solve for. So we're going to set this to sum because that's going to tell us what the total earnings would be. This is going to be our main objective cell, by the way. And we're going to set our total hours worked to sum as well because this needs to equal 200 hours in order to fill those stores that they need to have filled, right? Okay, so here's what we're going to do next. We're going to go into Solver. So it's the Data tab in the ribbon. We're going to click on Solver. First thing Solver is going to ask us to do is set the objective cell. The objective cell has the actual value at the end that you are going to maximize, minimize, or set to a specific value of. Okay, that's one of the biggest things. The big difference between Solver and GoalSeek, well, there's a couple, but one of the big ones is GoalSeek only gives you the ability to hit a specific goal. Solver gives you the ability to maximize or minimize your result as well as hit a goal. And on top of that, you have the ability to build in economic constraints, which we will do in a moment. So the next step is, so we want to minimize whatever is in cell F10. We want to minimize the amount of wages we're spending. Okay, minimize F10. Next step here is we're going to jump in and we're going to grab our hours worked as our variable cells. Okay, because that is what Solver is going to manipulate for us. We're almost there. Okay. So the next step we need to do is add our economic constraints, and we actually have quite a few. Okay, so let's go in. Here's what we need. Here's what we know. We know the sum of all the hours worked, which is going to be this, needs to be equal exactly to $200, or excuse me, hours. Okay, so let me stop and explain to you what this is going to do. An economic constraint, or when we build this in Solver, what the economic constraints can do is it can force certain variables to fall within certain constraints. So we know that a goal of this is that in cell E10 here, the total hours worked, all of these, have to equal 200 for this to get our problem met. So I go in and I tell it that cell E10 has to equal $200. Okay, excuse me, 200 hours. I just want to put that $200 in. 200 hours. Okay, so we still have several constraints to do. We have those full-time constraints and part-time constraints. So let's go ahead and plug those in too. Okay, so we're going to click Add. Okay, so our next argument is going to be this, or our next constraint is going to be this. All the full-time employees have to work more than or at least 30 hours. Okay, all the part-time employees have to work less than or at least 30 hours. Okay. All of our full-time employees also must work less than or equal to, let's go with 80 hours. Okay. So each one has to work less than 80 hours. Actually, I'm going to change it. We'll knock that down to 70 to make it more interesting. I'm going to click OK. So we've got 4 constraints in right now, and those constraints are the ones that are assigned out in this problem here, which we did in class. Okay. But the one next step that I'm going to add is I'm going to say that we can't work a partial hour, right? So you can't work a half an hour on your shift. The shifts go in hour increments. So what we're going to do here is we're going to add one more constraint that says that every single one of these hours worked have to be whole number integers. And I click OK. So we're going to cross our fingers here and hope that all these numbers come out to be something really wonderful. We're going to click Solve. And guess what? Solver found a solution to our problem, right? So the guy that works, and let's take a look at this. Now, before I go any farther, let me show you this one thing. When you do have Solver solve, okay, you have the ability to generate an answer report right here by clicking Answer Report. That will actually give you a formal report in Excel right there that shows you everything that you just did. But for you guys, let me show you what we did. Okay, and let's just show you what Solver did. Why we made this white text, we do not know. So let's go ahead and change that a little bit so you can actually see it. There you go. So here's the deal. Our schedule's full, 200 hours. The least amount that we're going to spend in order to get that 200 hours met is 2013.50. We've maximized the usage of our cheaper manual labor of part-time employees. So we've maxed out all 30 hours per person. Okay. We then moved and we took the path of least resistance with the full-time employees by taking the employees that make the least, 1025, having him work 70 hours, and then the most expensive paid person work the least amount possible in order to fill this in. And there you have it, Solver. Okay. We'll see you next time with another tips and trick. I think maybe Scenario Manager's up on the docket. Oops.